Hello everyone. Today I want to introduce some mathematic analyzing tools for you guys. Because I've been using Geometry Node for quite a long time, and there are some features that Geometry Node doesn't provide to us. So I just make it from scratch. Let's say what do we have? First of all is the simplest one, which is just the fifth corner here. It's showing the angle and the direction. And this is a very simple node group, and Blender already provide us a official node group asset. So, but whatever, I made it by my own. The next one is also have a curve point info, but this one is actually a bit annoying because I don't know, should I align it with the curve normal or not? So, uh, I just leave it as it is. So if you guys interesting, you can check it. The next one is the curvature. Here we can see if we're using the regular edge angle, if you use the edge angle, this node here, you will see some ugly this singularity points from the sphere. This is not ideal. And the dihedral angle isn't a proper curvature measurement. So here I provide two other ways, which is the Gauss curvature and the mean curvature. They are better curvature measurements. So as we can see, for this sphere, it should be all the way same for the curvature. And both of them, the Gauss curvature or the mean curvature, they are getting the same result. And for this cylinder here, we only get this curvature around this edge. And for this Susan, this one get a little bit different. So if we don't enable the absolute value, the Gauss curvature and the mean curvature will only show this positive. This one have a sign, so we need to use the absolute to visualize it. As we can see, this is a positive curvature, and there is also have negative curvature here for the Gauss and the mean curvature. And these two are again a little bit different. Then next one we have the measure centroid, and it provides three ways. The first is just simply averaging position, and we have centroid for the face. In case, for example here, in case you don't have a closed geometry, for example here, you delete two face, like this case, you wanna have this face island, but not a closed surface. So you can use the face centroid to calculate the centroid for it, or the volume centroid, which is a bit more accurate, and then have a group ID. Next, we also have a measure volume, and also have a group ID for it. Then the next one, which is the mesh synchronous. So let me show you about it. Let me just get this one here, which is just a Susan here. And let me calculate the synchronous. So here we can see this is our synchronous. Yeah, now this is a little bit jittering, so we can blur it a little bit to smooth it out. And it's also good to shade smooth it, okay? There we can see around the air or this part, it has a lower synchronous. And for the hand, this part, it has a bigger synchronous. Okay, this is a bit better visualization, and we can increasing samples to make it more accurate, but also it will increasing the calculation time. As you can see, right now it looks much better. I can still keep blurring it. So this is the mesh synchronous. And then we also have a simple coordinate plan for some visualizations in case you want to do some mathematic animations. So here is a simple coordinate planner for you. And there is also a simple debug to visualize the direction. And here is also 8 tools for some calculations. The first one is the circumcircle and the incircle here. So we can see here is our triangle. You can see the triangle and the incircle and the outer circle. By the way, this one works on 3D, so that means you can tweaking the vertex position in 3D and it is still accurate. It will give you the circle center and the circle radius and the circle normal, which is a face normal here. Here we also have a circumsphere and the insphere. So you provide 4 points here, it will calculate the, for example, here is the 4 points, it will calculate the insphere and the out circumsphere. So for example here, when changing the point position, you will see this sphere. Next, we have this one very useful tools, which is the gradient here. So here we can see this black and white image, which is the noise texture. And here is the gradient. It will pointing from the lowest value to the highest value. So this feature, I always want Blender to provide this gradient of a scalar field or the divergence of a vector field. Yeah, because these tools are very useful in some mathematical calculations or some geometry analyzing. So I made this tool for you guys. So here is the divergence. You can see this arrow shows in the vector field, and this one shows the divergence. So if the vector more divergence towards the out, imagine this is a source, and something pointing inside here. This is a sink. So the water will flow out from the source. So how much it flows out, it will be white. And how much it sink into this sink here, it will be black. So we can also enable the absolute. We can say this is actually negative value here because the water flow into this sink here. And the water coming from the source and flow it out. This is the divergence. And here we also have a least square fitting. So what does this node do? Basically, it will analyzing your position, and based on the position group, it will do something called PCA, which is Principal Component Analyzing, and it gives you the minimum direction, give you a direction that if you are plan, for example, here is your plan, and you project all the points onto this plan, and this normal will minimizing this distance from the point to project to the plan and accumulate all this distance. So this one gives you the normal here. And we also have a closed point pair. Here, for example, here we have 2 edges, and it will give you the closed point inside of the edge A and edge B. It doesn't require the edge to be intersect, and they still get the accurate result. So here is the closed point in edge A and the closed point in edge B. So for the P here, the P is representing the closed point in first edge. The Q is representing the closed point on the second edge. So you can visualize both here. As you can see, you can push it further, and you can see this point Q will stay on here because it can go beyond this edge. Also, it has three modes. The first one is edge detection. The second is the edge plan. You provide one edge and the plan one plan point to define where the plan locates and the plan normal here. Also the edge and sphere. This is the sphere center and this is a sphere radius. The last one is also very interesting one is the principal curvature. The principal curvature gives you the most curved direction and the most flat direction on the surface. So here we can see we just simply deform this sphere to get this irregular shape. And after this principal curvature calculation, you get two direction and also three curvature representation. And the K1, K2 means how much it curved, which basically is just the strength of the bendiness of the surface. So here the direction 1 is the most curved direction. In this example, this is a red arrow. So you can see here. Let me get rid of this. So if you look in the direction of the red arrow here, you will see that it actually following the most curved direction along the surface. And for this green arrow, it's most smooth direction, so it will be less bend of the surface. So let's take a look. It gets a very smooth vector field along the surface, which is very useful for something like this kind of a sketch or some particle you want to flow it along the surface. So this is all the node groups. Hope you guys enjoy it.